Hello, I'm James Martin from Scaleway. Scaleway is a cloud provider, a French cloud provider. We're part of a European telecoms group called Iliad. And I'm here to talk to you today about how to limit your cloud impact at all levels of the cloud, from the bottom, bare metal, to AI. And I'll be taking you through all the different levels of what you need to look at to keep an eye on your emissions and also the impact of your IT on the planet. So starting off, I'm British, but I live in France, and in France, France tends to be quite advanced when it comes to green IT. We even have a saying over there, which is called sobriété numérique. That doesn't mean trying not to drink cocktails whilst coding. It means trying to use as little digital resources as possible. So I just wanted you to, it's a really great and healthy principle. I wanted you to keep it in mind whilst you're listening to me. The second thing I want you to think about, it's if you can't measure it, we're used to saying if you can't measure it, you can't improve it. But increasingly in the cloud, what we're seeing is if you can't measure it, it's probably greenwashing. And I'm going to start off with an example, which isn't quite greenwashing, but it can be if you don't give it enough context. So here's just an example from Accenture. So they say that moving to the cloud from on-premise can reduce your emissions by up to 84%. Now that is the case if you do it properly, but it is very conditional. For example, if you move from on-premise in France, which has very low carbon intensity in the electricity, and you move to the cloud in Ireland, which has higher carbon intensity, then your emissions might actually go up. So that's why it's super important for any green IT, anyone who's looking to reduce their IT impact, to look at the whole range of options across data centers, hardware, and software. So those three pillars are super important. You can't just say, I've sorted my data centers, so I don't need to worry about the rest. Why are they important? Well, because we think that digital emissions overall are about 4% of all emissions, and that's quite a conservative estimate. But we think that 1% of those, of that 4, comes from data centers. The other 3, so 3/4, comes from hardware. And we can't give a percentage to software, but it's everywhere. So all 3 need to be optimized. Let's look at data centers first, because that's the sort of the foundations of the cloud. So the acronym that you'll hear the most often in the cloud when you're looking to choose your cloud provider will be PUE. It means power usage effectiveness, and it's a ratio which describes how effective your cloud provider is at managing the energy going into its data center to power all the machines in there. The global average is 1.55. As I said, it's a ratio, so the closer to 1 it is, the better. Scaleway's average is 1.37. The best we do right now is 1.16. You can see all of these indicators on our website. We're very transparent about it. But a lot of people just stop there. That's the first mistake to make in the cloud, because you also need to look at the broader impact. So how much water is your data center using? I don't know if you've seen articles in the press recently about local populations protesting about some data centers depriving them of water, but this is happening increasingly all over the world. So that's why it's a real priority for Scaleway. It has been for years, and that's why we always say that measuring WUE is just as important as PUE. So there isn't a global average as there is for PUE, but we can say one of the best is 0.18. Closer to 0 it is, the better. And that's Meta, but they're not a cloud provider. It's harder to find them for the biggest cloud providers, which I refer to as the hyperscalers. But Microsoft declared 0.49 in 2022. Scaleway is around the 0.2 zone. So that means that we are managing the water that we use efficiently, and that we are using as little water as possible. But those are ratios, so those are the best way to measure effectiveness, of course. But what about looking at things in absolute terms? Well, this is I put a lot of conditions on this comparison because, of course, I could imagine that Scaleway's data centers are way smaller than Google's data centers. But the fact is, that if you take our 40, the 4 data centers that Scaleway uses in France, that's how much water they consume. The 29 data centers that Google owns and runs throughout the world use almost 800 times more water per data center. This isn't to criticize Google or the other hyperscalers. It's just to give a point of comparison, and that is to say that that's an incredible quantity of water, and we don't necessarily need to use that much water. One of the reasons those big installations are using so much water is because they have cooling towers, and that's so obviously data centers need energy to run the servers and to keep for the whatever techniques keep the servers cool, and they need water if they're using a water-based cooling system, like cooling towers, which are huge installations, a bit like if you've seen a nuclear power station, it's a bit like that but smaller, but the principle is similar. And these things can use up to 25 liters of water per second. It's just mind-boggling amounts of water. Cooling towers are banned in France, so we couldn't use them if we wanted to, but we don't, because we consider that water is just as rare a resource as energy, so we need to use as little of it as possible. Another way we use low water and low energy is we use alternatives to air conditioning. So we have a data center, our partners called Opcore, also part of Iliad Group. They operate it, and we're very proud of it because you can say it's one of the most sustainable data centers in Europe, because it's the one that has that low PUE, 1.16, and it hardly uses it. It uses very little water, but most of all, it uses no air conditioning, and air conditioning accounts for 30 to 40% of most data centers' energy usage. So instead of using air conditioning, we use 2 techniques. One is called free cooling, which is basically passing the air from outside over the servers to cool them down. And when it gets hot in summer, we use a technique called adiabatic cooling, which is basically passes the air through a wet membrane, and the water in that membrane cools the air down by up to 10 degrees. So that's a sort of simple, natural way of cooling down servers, which works just fine for us, including for our AI GPUs, which I'll come back to later. I also mentioned what's the importance of what is your carbon intensity in your electricity. That's super important. France is very low because most power in France comes from nuclear or hydroelectric. So if you're moving your compute workloads to France, then you're immediately having a lot less impact. You can also choose cloud providers which use as much renewable energy as possible. And the more transparent their reporting is, the better. And I would very much urge you to look for location-based data, which is not, this is the most accurate type of emissions reporting, but not everyone is using it today. So that's the first part. The second part is hardware. So as I said, that's 3/4 of digital emissions, and it's important to consider hardware's emissions at 2 stages. Of course, there's the energy that the hardware uses on a daily basis, but before that, and a sort of a bigger picture, is what we call the embodied carbon. That's the emissions of a product's entire lifespan. So looking at that is called life cycle analysis, or LCA. It's this diagram which shows that the product's impact comes from its manufacturing, its distribution, its use, and its recycling, and above all, its raw material extraction take the example of an iPhone, 80% of its impact, and it's Apple who said this themselves a few years ago, over 80% of the emissions of an iPhone come from its manufacturing, not from sort of plugging it into the wall every day. There are ways to measure this impact directly in hardware. So IPMI, for example, is something that allows you to plug straight into a server and to get all sorts of stats out of it in terms of its energy performance. You can even get details like the fan speed of the server from through this protocol. You can use LM sensors. You can use, and if you're using Intel processors, some of them have a protocol called RAPL, which allows you to directly get the real-time statistics on how much power your processors are using, and then you can do a proxy between power and emissions, again based on the carbon intensity of where you live. So those are the components, and then there are tools. Scafandre is a quite a well-known French tool. PowerStat for Linux, Energista, which is made by Boa Vista. If I didn't say it before, Boa Vista are a French association, and they are the real experts of measuring life cycle analysis. You should really check them out if you haven't done before. They have some great resources online. And you can, and the good news is that these principles are catching on even with the biggest manufacturers. So if you want to buy a Microsoft Surface computer, for example, you can check out the price, but you can also check out the emissions before you buy it, so you can make a more responsible choice. So I think you worked it out. The way to reduce the impact of hardware is to make hardware last as long as possible. It's very simple. I'll go back to the iPhone example. If I make my iPhone last for 3 years instead of 2, then I have reduced its emissions by 50%. It's similar for servers, even though their balance of emissions is a bit different from an iPhone. But anyway, what we try to do is keep as many servers going for as long as possible. So we recently industrialized our project called Transformers, and we have 1 or 2 others. The main one is Transformers. Those are the green bars there. And we, under these programs, by industrializing them, we've doubled the output of these programs, and they will. So we're looking at something like 80,000 servers reconditioned by 2025, and that is twice as long as what some of the hyperscalers are doing at the moment, as you can see from this the graph from Apidays, which is a French consulting firm. Code and software is I'm going to be honest here. We're just starting to dig into this part of things at Scaleway, but we do have a big news to tell you on this front. But before I get into that, I'm going to talk to you about what coders can do to reduce their impact. This is just one slide. There are lots of amazing resources out there. I'm thinking especially of Anne Curry and Co.'s Building Green Software, which is an excellent book if you want to go deeper into this topic. But the basics of green coding means there's not much difference between green coding and clean coding or efficient coding. So the cleaner your code is, the less energy it will use, and the quicker it will get the job done. So developers can do a lot of things, but what about managers? Why do managers not give developers energy efficiency objectives? If they have the right tools, then they should be able to manage their energy efficiency. Why not do a green hackathon to see who can produce the most energy efficient app? It's not difficult to do. Some of the things developers can do is a simple one is carbon aware computing. If your cloud provider allows you to shift your workloads to France or Sweden or another low carbon country, you should do it. If you can run your workloads at times, there are times of day when the carbon is higher and lower. If you can run it at lower times, again, you're reducing your emissions. there's a fantastic Green Software Foundation course called Green Software for Practitioners, which you should really check out. You can measure your code efficiency with all sorts of tools. Cyclomatic complexity means reducing the number of steps between to get from A to B. And then you'll see that some of the tips that apply to code are also applied to hardware, because that makes sense, doesn't it? I mean, the longer your code can last, the less you have to rewrite it, so the less energy it will take to make new code. And also, very, very, very importantly, the longer your code can last, the better it is to stop hardware becoming obsolescent. So that means that you might note another iPhone example. Your phone might be too old to run the latest version of Instagram. Instagram should be coded so that it works with as old a phone as possible. I think. Now, I'm not going to get into another iPhone example. We're not here to talk about iPhones, but they're the absolute gold reference, gold standard in that is Fairphone, and they're trying to make their phones last for 10 years, which is absolute ideal. And why not apply that principle to all hardware? And software can help with that. So here's what our big news in terms of measuring impact, and it is a software product that we're in the process of finalizing. We want to release it in public beta by the end of the year. It's going to be called the Scaleway Environmental Impact Calculator. And the reason we've called it that is because it doesn't just measure carbon. If you look at the other calculators that exist today, they only measure carbon, they only measure emissions, and they don't always cover all scopes fully. I wanted to especially bring your attention to two columns here, the hardware column and the water column. So we are going to be offering a complete analysis of hardware or life cycle analysis. As you can see, some of the other providers, 1/5 from commissioning, for example, means that they'll imagine that a server will last for 5 years, so they split that impact over 5 years. We're going to be going deeper than that. We've got the data to be able to provide way more granular analysis of life cycle, and it won't be in the first version, but we will ultimately be working in water. So Scaleway clients will soon be able to know what's my emissions impact, what's my hardware impact, and what's my water impact. Nobody's perfect, of course. We're going to be releasing this. We're building this in-house. We insist on building everything in-house on open source standards. It's one of our golden rules at Scaleway. So we're going step by step. The first version of the calculator will work with bare metal, and it will give our clients a monthly report of their emissions when they get their monthly bill. So we start with bare metal, and then we'll add the other layers of the cloud on top. And one day we will get to AI, which is the next thing I wanted to talk to you about. So AI, we can't not talk about it because I'm going to stay on this slide for now. Scaleway has, as of last year, the European cloud's biggest AI compute capacity, because we have clusters of several thousands of GPUs, which allow people to do all manner of workloads. But we're also conscious of limiting the impact of those GPUs. So they are housed in the DC5 data center, which I mentioned before, which means they're probably the only AI GPU clusters that, to our knowledge, which are not cooled by air conditioning. That's one way to limit the impact of AI. It's not really talked about that much today, but when we do talk about the impact of AI, we mostly talk about the training impact. So it's fairly well known that training GPT 3.5, so the previous version of the model behind ChatGPT, is generated 552 tons of CO2 equivalent. That's approximately the average. That's what 50 French people emit in a year. So it looks a lot, but it's not a huge amount. However, what does when things do start getting huge is when you talk about usage, because it does cost energy, it does generate emissions to use ChatGPT and other similar models, of course. But it's been worked out by an ONG in France that using generative AI tools like ChatGPT can be 200 times more impactful than training. All of the sources are linked to here if you want to find out more about this. And so that's the emissions or the energy impact. And there's also the water impact. It's been worked out that having a chat with ChatGPT is the equivalent of, oh, look, I've got one here. This was full, dropped it on the floor. That would be the cost of a chat with ChatGPT, because that's the water that's required to cool down the servers with the GPUs in that are providing those answers. And then, so most I've been talking about GPT 3.5, the latest version of ChatGPT 4.0, it's been estimated, because we don't know, we don't have the exact figures, but by comparison with similar models, it's been worked out that that using ChatGPT, the latest version, can generate up to 25 times more emissions than the previous version. Why is that? Well, get a surprise, it's about hardware. Most of the activity I've just been describing is happening on GPUs rather than CPUs, and GPUs consume 4 times more energy on average than CPUs and generate 2.5 times more heat. So this is a big reason why global electricity consumption could double by 2026. According to the IEA, the International Energy Association, and they say that AI, data centers, and crypto are a big driver behind that increase. So how can I mitigate that impact, and how can I measure it? Really, the two go hand in hand. First question, do I really need to use generative AI and LLMs? There are other types of AI that can do the trick, depending on what your need is, using a lot less energy. Can I use an existing model? So there are a lot of models. Hugging Face is the global reference for, you can pick any model you like, and a lot of them can be fine-tuned to meet your needs. So if you're using a model that already exists, you're wiping out that cost of those training emissions that I mentioned before. Can your model be open source? We're seeing an increasing number of open source AI models, and they are becoming more and more comparable with the closed models in terms of performance. But there are other advantages, that because they're open source, they're transparent, and you can measure their impact, whereas you can't with the others. Of course, I'm going to say this, but it's very important. If you're choosing to do AI, you should make sure you're doing it with the right cloud provider that tries to reduce the impact of that work. So only uses renewable energy, uses little air conditioning as possible, and as little water as possible. Remember how important I said that was. You could also ask, if I was talking about the difference between GPUs and CPUs, if you have to use GPUs, because actually CPUs can work for some inference workloads. Scaleway works with a partner called Ampere, whose CPUs consume 3 to 5 times less energy than NVIDIA GPUs. And of course, so you should be able to measure the impact of your models. There are lots of tools out there. The one that I've been quoting figures from is called Ecologits. It's a great project which was born out of a French ONG called Data for Good. And the way it works is that it measures the inference impact of closed models by comparing them with similar open source models. And the result, I've given you some of the results already, but you should really go and check it out if you want to know more about this. So that's it. The takeaways are pretty straightforward. This is actually more of a recap of what I just said. I've managed to cram it all into one slide. If you want to stick that on your wall or on your fridge, it's just it's a checklist, if you like. But in terms of the principles that you should be applying and what I've been talking to you about is it's across the pillars, isn't it? It's use sensible, simple coding that only does what it needs to be doing. Think about the most famous pieces of software. Do you use more than 10% of their functionalities? No. So keep it lean, keep it simple. Try to make sure that hardware can be used for as long as possible, and we've talked about the important role that software plays in that. Don't make websites too heavy, don't make applications too heavy. One of the things we learned yesterday is that if you put a video on autoplay in the background of your website, it increases the weight of the website and therefore the energy impact by 75. It accounts for 75% of the weight of the whole website. You don't really need to have a video on autoplay to make your website work properly. And last but not least, choose the right cloud provider, like I said, which is working to reduce its impact and which is reporting in a transparent way on how it's doing that. That's it. So if you want to find out more about how Scaleway works to reduce its impact on the environment, you can check out the QR code on the left is to go and see our environment page on our website, which includes the impact report. It also includes our Green IT white paper. This presentation is essentially a condensed version of that presentation, so of that white paper. So if you want to go and dig into there, it will be updated as of the end of September 2024. So you can go and check that out. And if you have any questions, just drop me a line. That's it. Thank you very much.